Hi and welcome everyone to this episode of Breakpoint. The topic for today is AI for offense and defense. Our guest for today is Tamaghna Basu. He's the founder and CEO of DeTaSECURE. Microsoft came up with a Twitter bot for themselves. This was around 2016.
Real life, it's not an AI problem, but you actually have a possibility of creating something which causes a much bigger chaos in the system.
In Indian elections, where there were talks of such videos being out where we had deep fakes particularly in place.
But jailbreaking is a way of doing, and it has the internet access.
Welcome to Breakpoint Security Podcast, folks. Join us as we explore the fascinating world of smart security teams and their cutting-edge security and engineering practices. We'll share fun and engaging stories about clever optimization techniques that scale your defenses and also keep your data safe. Tune in and be a part of the conversation where exciting innovation meets real-world application in cybersecurity. Hi and welcome everyone to this episode of Breakpoint. The topic for today is AI for offense and defense. Our guest for today is Tamaghna Basu. He's the founder and CEO of DeTaSECURE. He's also founded two other startups. His expertise is in AI security and Web3. He's a member of SuperteamDAO and he has spoken at multiple international conferences, including BlackHat. He's also the mentor at Stanford and many other places. Welcome to Breakpoint, Tamaghna.
Thank you, Neelu. Thank you for the opportunity. It's good to be here and happy to have an interesting and engaging conversation with you.
So I was just remembering the GPT thing, and I was going to name the episode to be Tamaghna GPT and Neelu GPT, and then I realized that people will not relate. So maybe post the episode and people have watched it, I'll do that. For now, so today, there is a reason why we are talking about AI. It's been good few number of years that AI has been there. It's been there for a while, like good few, as in more than a decade that I've been hearing about it. But then recently, there was a lot of development and maturity that we saw in the LLMs, the large language models, the natural language processing, whereby AI can now understand the language in which we speak or write, and that has given birth to a lot of things, and it of course has a great impact in security as well. And while I was talking about various niches in security, so we in Breakpoint talk about various domains, we always touch upon AI because there is directly or indirect impact of AI in each and every subject that we have. And I thought, why not have a full-blown episode with an AI expert like yourself and actually explore what we can do with AI, both in offensive security as well as defensive security. So with respect to that, many of us would have heard about, so just for the audience, we have heard about recently, particularly in the last 2-3 years, a lot of breaches and attacks that we keep hearing about, with relation to AI. For example, Microsoft came up with a Twitter bot for themselves. This was around 2016. This Twitter bot was called Tay, and this was AI enabled. It could understand and respond to tweets from people. And when that happened, I think it was within a day that they had to take it down with an apology. And that apology actually was because it started using abusive chats and racist chats against people and started responding in ways which were unexpected, which were hurting for people. And that's not just the one use case where AI went wrong. There have been multiple other breaches in the meanwhile in the last 2-3 years itself. A few, for example, like TaskRabbit, where we had millions of records which were affected, millions of people and clients' data that was taken away. And when they investigated further, they found it was an AI-enabled botnet. So there is the botnet, and then there is AI-enabled botnet. The point that I'm trying to bring forward is that AI is also powering a lot of offensive attacks today. So particularly in the domain of information security. And just wanted to know what's your thoughts on that, Tamaghna.
Yeah, definitely. So, I think I keep telling people, right? So, AI is just the next stage of evolution from automation. So
Yeah.
typically, initially there was like manual. We used to do a lot of things manually. Then obviously, thanks to Python and other lot of the scripting languages, that we started doing a lot of automations that made our life as an ethical hacker or as an offensive person or whatever. It make life easier and faster. Simplify a lot of this kind of attack. And then also because it becomes simplified and faster, so they can do it at scale. So that was the first phase up. So AI is like the extension of that. Now, a lot of this kind of intelligent decision making, because automation is just a way of doing things, but the final decision making still was with us as an security expert. Now, when we actually think from a decision making point of view, now thanks to AI, now there are a lot of this kind of decision making and branching can be done in a much efficient way, where the possibility of having success and reducing the false positive is kind of high. Like, so essentially we can have more success rate. So yeah, so as a result, that it's reducing human effort. It's
Hmm.
improving the sort of accuracy in terms of attack strategy and success rate, and that actually making life difficult for the normal users. Yeah, that's what I can say.
Yeah, yeah, so true. But with respect to, since most of our audience are, into offensive security, or
Mhm.
ethical hacking, where they get into authorized engagements with clients and are checking
Mhm.
for their security, or are, trying to provide them with the vulnerabilities that they have. What do you
Right.
think are the best areas where these teams can
Mhm.
actually use AI for security operations?
Yeah. So I think if I look back and in terms of adapting AI into the area of cybersecurity, how we see it initially, it started with monitoring aspects, anomaly detection, or in general, it's a very aligned with one of the concept in AI field called outlier detection, right? So there is a pattern,
Hmm.
there is a data which goes in certain pattern, and the objective is raise and figure out what are the data which is out of the pattern. So that is where one of the very easier and convenient use case where I see or I saw in the past the AI has been implemented, which is more to defensive, but essentially that actually leads to more intelligent UTM devices or firewalls. So kind of rule reduce the usage of rule based engines and use more of AI or ML models. That's where it started, and that's still valid today. So essentially, the first level of recon, because recon is a very lengthy or very tedious task. Like there are so many data, in terms of if you talk about a pen testing process, right? The first stage is information gathering. You have to have a huge amount of data gathering, depending on black box versus white box, what kind of testing you're doing, port scanning, servers, and if you're doing like at scale, like there's a lot of things you have
Hmm.
to do. And out of this data, you have to figure out those very specific, loopholes. Because if I remember my days where we used to do again, the OSCP and other kind of certification, which is more of hands-on driven.
Hmm.
There's so many options of creating attack strategy. You don't know that which way to go. Now with the
Yeah.
help of AI, this has, because now we're talking about an AI which is, think of it like a mentor for you, which has been trained with a lot of this kind of scenarios. So this can be like a co-pilot and support in terms of creating, what, there are three options out of that. This option has a higher probability, and why to go ahead with that. So that is one way I see that can be used of, in the first stage of attack strategy, use this data, feed in the data to the model. And probably if the model is trained with the right data and it is actually well trained, this can give you the right direction in terms of how we can proceed further in terms of attack. So that could be the first stage which I can think of. The second is obviously once this has been done, now the other area of, let's say, if you talk about offensive attacks, right? How smartly you create your attack vectors, right? Or in pure all the payloads and kind of stuff, right? So if you talk about those good old days of using Metasploit, we have to do obfuscations because the payloads can be detected and all this stuff. Now,
Yes.
all this kind of this mundane task can be simplified and automated using AI today, where you can say, what, look, I'm trying to attack this platform, this version, this probably I found as a data as a record that they have a firewall or
Uh,
something like that.
can
Can you
you
create a?
can you explain, like, just for the listeners,
Mhm.
Metasploit and what it does? Like,
Okay,
is it-
so Metasploit is an exploit framework. Okay, I don't know what stage it is right now, but very long back earlier, this was open source framework, exploitation framework, which is a tool where there are a lot of exploit techniques has been already been built and kind of incorporated, which someone can use to hack into a box. So basically,
Ready
let's
to
say
use.
ready to use. It's a ready-made exploitation toolbox which has a lot of, think of it like a weapon kit. Like you have all the arsenals with you, various hacking techniques. Let's say you want to exploit I'm just saying, let's say like a PDF reader on a Windows platform, probably a Windows XP or maybe a Windows XP. I'm just talking about a very old example, legacy
Yeah.
example. So this Metasploit as a platform has all these exploits written for that, and which someone can use to actually create your attack. And if all goes well, it will exploit and you can get an access to the server or whatever you want to do. You can shut down, you can format, you can delete, or whatever you want to do. So that is the second part of what action you want to do. So that is called payload. So first part is exploit, which you use to like a break into the box. And second part is once you are into the system, what you want to do. That is a payload part. Now, this payload are very popular. So a lot of time firewalls, they detect that. They identify that, this is the pattern now, this is the signature. If it is an executable file, what would be the like, attack signature? So that is where the concept of obfuscation comes, where you try to obfuscate it in such a way that, it will work, but then it will not be detected by the system. Just to give a very lame example, let's say I have created a rule that if a value of a variable is 4, then I will block it. But let's say if I put that way, that value of the variable is 2 plus 2, maybe the my rule may not work. So that is called obfuscation technique, right? How you create it is the same result but create in a different format. So obfuscation is a very tedious task in general if you try to do manually, although there are rules available. But I'm saying these are the various things where AI nowadays can help. And one of the very interesting thing is polymorphic malwares. Like malwares can shape changes, right, depending on the platform.
Yeah.
So those are the various interesting use cases where I see that using AI, it can actually identify, what, now I'm getting flagged. So why don't I change my shape? Something like that. I'm just saying a very simple example. These are the new trend of attack or new kind of, I can see the new generation of, let's say, Trojans or malwares are coming because of AI.
Yeah, it's great that you gave the polymorphic malware example. This we were discussing this in our episode 1 in season 2
Mhm.
with Sham, and we were looking at how it had become sort of a big menace for us, especially in the pandemic when there were so many different kind of malware. But now they were changing shape in the sense, just to also simplify for the audience,
Mm.
they are, so every malware is detected generally traditionally as a with a signature, which primarily is trying to also detect what is the hash of the file. So when you hash the file, generally there is a single kind of hash. What happens in polymorphic is that hash can keep changing now because and then the signature will not match, so you are not detecting that malware anymore even if you are an antivirus on the system. So this is what polymorphic is, and I think it's a great example of where it can be used, particularly on the offense side.
Now,
All
just
right.
to add to that, uh, like if you talk about what are the other use cases people are using, now there's a new generation of attackers coming because of AI, thanks to AI, which is empowering us on a lot of new things. So that's why the deep fakes and other things we're seeing, into coming into the picture. So there are a lot of new innovative use cases also. That's
Yeah, yeah. So talking about deepfake, actually, this is one of the big thing that I wanted to also quickly discuss, and this relates to not just people who are in security, but in general anybody who's out there, is that we are seeing a lot of use of AI, particularly in phishing. Creating emails which are now grammatically absolutely correct. They are of course the intention is fraud, but now there is no mistakes that we generally would do or a script kiddie would do when writing those mails. So there are good phishing mails being created with this. There is voice simulation in place where you would have heard of recently a lot of news where people are trying to actually simulate the voice of a person and trick another person in the family to be able to do something, which if we extend in the business context will mean that you could have your boss's voice calling you and telling you that, hey, do this or do this transaction, which is equivalent of the business email compromise that we used to see earlier. So a lot of that, and the deep fakes where it's very difficult to, so in an image it's very difficult to say that is the same person, so you can actually simulate another person or fake another person. But since you've used AI, it's very difficult even for normal programs to detect that it is a fake image. So it seems like it has become way more convincing by using this. How easy? And have you seen any other use cases, Tamaghna, for similar kind of activities that people are using it for?
Yeah, so basically the way I see it, yeah, so phishing is on definitely area. Phishing, wishing, and yeah, voice simulation, deep fakes. Uh, these are the one area. The other area is actually we are talking about like using AI to attack another AI. So
Oh,
that is
okay.
that is
This is
basically
interesting.
yeah, so that is where it comes. I mean, obviously, a different kind of attack is there, but fooling a model, like how can I fool a model with creating different kind of thing? If I know that there is a sort of, just think of it very simple. If there is a facial recognition system, and I know this is a model which has been built, it's a machine learning model, which is built with the data, and can I do something which can allow me to bypass the model, right? So there are those kind of things are also happening. It's like so tech is against the tech, right? So yeah, and essentially what is happening if I can build that, one is actually to bypass kind of attack. So attack in terms of category of attack, it's a bypass or evasion attacks coming,
Okay.
which is more of like you as an attacker fooling a system, or yeah, system as in a system in place, right? A validation system or whatever you call it. Other is actually through this process, a lot of time, the other kind of pattern I'm seeing is, people are trying to poison the model. Retrain, if there is a way I can poison the model by training with malicious data, eventually that will start either having a bias problem or having a false detection problem. And
Can
that will
you
eventually, yeah,
can you give an example of this?
yes. So for example, um, okay, let's take an example of Dave, right? The Microsoft, the one
Ah,
that's where
yes.
we started.
Okay.
So again, I don't work in Microsoft, so I don't know what exactly went wrong there. But what is my understanding based on my experience and what I've seen is a lot of this model, what they do, they behind the scene keep getting retrained on the data which has been fed into it. So the way it happens is first phase of the model gets released, and then there is a continuous learning process happen behind the scene where whatever the current execution happening, current data set is coming, people are interacting with that. So what I feel is probably the way might happen then when this retrend went wrong, when it's actually probably going on, somewhere somebody actually feeding in something which actually considered to be probably considered as a data point, and in such a way it's the model has been poisoned so that it starts spitting out the kind of the unwanted things, right? This is what I have also seen a lot of. So I personally have used one use case of again, same bypassing kind of facial recognition kind of model, where there's an API which ideally should be authorized or access controlled, but there's an API through which you can feed in data to train the model while it was live. And if we can get those
Okay.
kind of access, we can actually feed in data saying that,
Uh-huh.
this is not Basu, this I send my picture and say, this is Neeru's picture. And, why don't you go
Oh.
ahead and train it? And if that access I have some kind of API. So it is not per se a API problem, it's a design problem, how it's been designed and deployed, right? Someone actually have created this retrain API, let's say, and that's been exposed by mistake without having a proper threat modeling, right? So as a result, I have an access and I can feed in those data, retrain the model. And if that model is in action in real time, and I then know that I can actually now bypass or fool, or even that will impact the other set of customers, right? So it's much more dangerous because the first set of phishing or voice simulation difficulty is more of a target. It's a one-to-one. It's more
Hmm.
of a B2C attack. But now
Hmm.
we're talking about a B2B kind of thing. We're talking of poisoning a system which is in
Hmm.
place. For example, this validation of face recognition for, let's say, in the airport. If some way that gets spoiled, now it will actually impact the entire demographic. So that is a
Yeah.
much more
Yeah.
bigger and scary kind of use case or possibility we see is there today exist.
Yeah. I mean, I would, on a lighter note, call it face injection. I think it's coming our way in a way, but
So there's a term we use for this called model injection attack, like SQL injection and
okay.
process.
Okay.
It's called model injection attack. We try to inject the data into the model and poison the packet.
Yeah, good that we have standard names for this. Other people like me will give weird
Yeah.
names. So, but talking about that, it can definitely have. So, when you extend that to demographies, like you were saying, or regions or countries, and think of elections and other scenarios, these things can become definitely way more dangerous. And we have seen that, I think, especially in Indian elections, where there were talks of such videos being out where, we had deep fakes particularly in place. But model injection, so when you're talking about model injection, it's a much bigger thing, and the poisoning is a much bigger aspect where the entire system gets poisoned for the
Yeah.
kind of data that you have mistrained it on,
Yes. Yes.
in a way.
See, it's a the way I see it is at the end of the day, is a human nature problem. Nowadays, majorly all the information is consumed through digital platform.
Hmm.
Everybody, right? So we no longer, I think, I don't know how many of our friends still read newspapers nowadays, right? And because this happening, first of all, there is no validation of the source of the information today. There is no way you can validate, and people don't do that. People don't have that, neither, even if they want to do it, they don't have that kind of bandwidth or the attention span to actually do that. And as a
Yeah.
result, what is happening, these kind of issues are coming where this whatever you say, the deepfakes or fake videos of propaganda based thing,
Hmm.
the deepfakes and all this can actually cause a much bigger problem on the real life. It's not an AI problem, but you actually have a possibility of creating something which cause a much bigger chaos in the system.
Yeah. Yeah. So while we have been talking about how AI is helping, ethical hackers, I also wanted to understand what are the areas where it actually becomes challenging to use AI for attacking or even for official engagements.
Yeah. So basically, see, again, I think one thing you rightly put there is, it's been there for decades now. Like we're not doing something which is newly invented. You talk about machine learning algorithms, so whatever they are, models, neural nets, and all this thing. It's been there. It's been all the big university. If you go, there are courses people have been studying. The the point which is actually make it so high, and this concern, all the new things are happening, new age attacks are coming as a result of availability. Now the technology is available, the infrastructure is available. So the first initially it was, let's say, there was not much model, like and when the TensorFlow wasn't there, right? There was not much enough libraries to use, probably, at a scale you can build something and deploy and something like that. Also in terms of GPUs, right? Let's say the other earlier days, there was no infra to train the model. So first challenge, if I say my experience, which I faced initially when I was creating a model, is the infra problem. It was so expensive. I don't have enough computes. I have to, even if I'm using AWS or something. I remember this talk I did, right, in BlackHat 2 years back about how I clone myself using AI. You won't believe, to build a very basic POC for that, I have burned, I think, around 15,000 to $20,000 worth of credit. Uh,
Oh.
so so that is the kind of amount of resource crunch was there initially, and it's still there. I think if you want to build something very realistic today, it is limited by two things. One is data. You need a volume of data, and so if you talk about stage by stage, first is the data collection. You need to have right kind of data.
Okay.
So where do you get the data, right? Based on your problem statement, do you have enough data or not? Is very much required. Now, even before that, how do you define, how do you understand, do you have sufficient data or not, right? Do you have that maturity to actually understand that, what, I have 10,000 record, is that enough? Or do I need 1 million or do I need 10 million? So when I was building my first model in UI, which is about, behavioral AI, we are, nobody solved this problem. This was like a first of its kind of problem we are trying to solve, and we didn't know how much data is required, what data was
Okay.
required. Right. So if so in the entrepreneur world, we say, are you solve if you are doing a category creation problem, if you're solving something which is new,
Huh.
you don't, a lot of those things are not clear. So data collection is a big problem. Data labeling is a big problem. Are you actually labeling it properly? Are you actually when is the data is a group of features or properties? Are you actually looking into the right kind of properties to train the model? Right. Third is, the model accuracy and bias, right? Are you actually overfeeding the data? Are you actually overfeeding the model, right? Are you giving more than the data is required? That also causes a lot of time problem. So it's a mix of infrastructure issue. Like you need proper infra, proper data, and you need proper expertise. Like all three things comes into the picture, and nobody defines what is the standard for that. It's just learning by doing. That's what I feel. I have experience in my life.
So with respect to what you were talking about, I was just thinking, so there is one aspect which is the quantity of data that it needs to be trained in the first place.
Mhm.
And many
Mhm.
places where you know that the data is very less, you can't even think of having such models because they will not be effective. But when you have enough quantity of data, so for example, I was thinking of it in the with respect to having machine learning that we use to break captcha. So suppose today we use
Mhm.
uh, as an attacker, as a hacker, basically, if I use machine learning and I am breaking a captcha which is text based, tomorrow the entire data set may change to an image based one, and
Right.
after that you may have some other advancement that has come in. So when the data set, the data type itself changes, that is that also a challenge?
Yes, yes, definitely. So when I say data, so continuous learning is always a problem, and you have to do it. It's basically how far you want to extend your model to solve the problem, right? For example, this capture thing you talk about. I myself have done this, right?
Oh,
So
great.
when initially when I've done it, we did it like very basic model. And if you talk about first version of capture, like you talk about old days, like there is very basic
Hmm.
captures was there. So there was, I remember there was a talk long back I attended somewhere, which is somebody has used OCR to actually parse the text, characters into the capture, and they have kind of did it. They didn't require like another model or something like that. But in my experience, what I've done is first set of data is very simple. So I could train with entire capture stream my model, and it was working. But then there came the second type of capture, category capture, where the text characters were tilted, like something like this.
Hmm.
W was
Hmm.
like this,
Hmm.
I was like this,
Yes,
like that.
yes.
So it was tilted. So the moment it was tilted, the same W was appearing somewhere straight, somewhere like this, somewhere like that. And because of that, my data set was not sufficient now. And when I say data set is not sufficient, it's not about the data product, it's how I interpret the data. So it was the same data
Yeah.
set I used, but instead
Hmm.
of now adding the entire capture string as the training data, I have to break it down in small characters. And I have to create all possible combination of W and say, you know what, W will look like this in your real capture. So
Oh,
as a result, I have to
okay.
create a separate model which knows how to detect a W when W is this, like that.
So your
So I have to
permutations will increase then.
exactly. So, and then my model
Okay.
also changed. And then I have to move to CNN, a convolution neural network. Earlier, it was a normal neural net kind of thing. So, because why? Because CNN, by definition, is a model which actually solves, do a faster way of recognizing, disposition based, let's say, model. So, a very, in YouTube, there's a good video on that is how a CNN can detect a koala when koala is upside down or downside up. It's the same model
Yeah.
will work
Oh, nice.
because it does using certain patterns. So by definition, there is certain model is built for this kind of problem statement. So now because of that, I have to shift to a new algorithm. So that is what the skill set and understanding. So had I not
Hmm.
know about what is and how does it work, I wouldn't have thought about that, uh, think about breaking my head on data. So coming back to my three problem is the data problem. Data has a collection and interpretation. Second is
Hmm.
a knowledge problem. And third, once I do it, now I have to train it. Now, when I try to train it with my, let's say, local MacBook, it fried. It couldn't work. Then I have to actually create a new infrastructure, with some higher processors and all this thing. And then it took a while to train it. So that is how it. And then the last level, which I could not work, was just strike through. So there was in strike through ways. And nowadays, forget nowadays, so recapture and all this came. So
Hmm.
it is always changing, right? So as a result, then if I am talking from an adversarial layer point of view, I have to also upgrade myself. Otherwise, I'll always be obsolete.
Yeah, yeah. That I think that just keeps going on with all the advancements that we see. Interesting. So, we have been talking about the attack side until now, and I was very curious to hear from you, especially given that you have a lot of experience in developing these models, training these models. You've written it, you have, I think in earlier companies also, you have worked heavily on fraud detection and other areas as well using such models. There was one problem statement that I was very curious about, and this comes from my recent, so in the last couple of years I was also going through these some of these cases where AI actually failed. For example, people were successful in fooling the AI. So there was this experiment that a bunch of researchers from Tencent were doing on Tesla Model S, and Tesla Model S is AI enabled in a way. The system that within Tesla Model S was lane detection system. To us, to normal humans, it'll feel like, okay, for detecting lanes, now you have an entire model, and because you need that, because the way lanes are painted, the depth of it, and the way they diverge from each other, all of those things change, and they change between countries also, right? So that's not uniform. And they were able to fool it by having stickers on the road, and were able to actually confuse it to an extent that it started misbehaving, and the car was moving here and there. And the Model S, which was AI enabled, essentially could not perform and could not have detect the lanes correctly and kept moving here and there. So in a way, they were able to fool AI in that case, and there are many such cases where these experiments are happening. So I wanted to understand, in your experience of developing these systems, how do you actually understand that these edge cases will be there, and also how to secure your ML models?
Okay, that's a very interesting question. Yeah, there's, I would say, I don't have a right, I mean, straightforward answer to that, to be honest. I can share my experience.
Okay.
So basically, there are two parts to this problem. First part of the problem is AI gone wrong, right? So where, basically, uh, there are multiple things, rogue AI and other things we can say. But then the idea is basically, one part is, yes, um, so basically, how do I put it? So basically, there are,
We can take a pause.
okay, so basically, to answer this question, so there are two parts to this problem. One part of the problem is, I would say, the way I see it is, one is the obviously the data problem, in terms of, you don't have sufficient data probably to train the model. Otherwise is adding noises. So I'll explain what is the problem, what does this mean. So if you don't, let's take about this lane problem, right? So lane problem could have been in two ways to look at it. Let's say you have trained only with data where the lanes are on the left, the car's supposed to be on the right side and driving. And if you try to use it on let's say a country like India, where the car's supposed to be on the left side, right? So it's tricky. It is biased. It is not trained with the sufficient data. So sometime what happens is the use case for which has been trained, it's not trained with the right data, and as a result, it has certain kind of biases. And we've seen a lot of example like that. And one of the example is racial bias, which is pretty pretty big concern in a lot of cases where,
Uh,
let's say, if there is certain kind of so there was an incident I remember in the US happened. There was a Department of Justice was using an AI model where it's supposed to predict a convicted person who is, let's say, faced his or her time and got released. What is the probability of that person committing a crime again? And it was, the model was unfortunately trained with a lot of biased data, and as a result, it was more biased towards dark skinned people, saying that they have more probability of committing crime versus a person with white skin. So these are the various
okay.
things was there. It is also basically the problem of the person who was designing the data science, or the engineer, whatever you call the person who was building the model. Is this person have thought through all possible use cases or not, and then has sufficient data for that or not? The other point what you're talking about is, if there is certain limitation, because see, at the end of the day, there will be limitations. If there is a limitations like this, and the use case you're talking about, this Tesla, where people are putting stickers and stuff like that, these are called adversarial patches. So a lot of this kind of stickers available, what it does is actually looks like a pixelite sticker kind of thing. And if
Okay.
you wear it, and when the camera actually looks into this, and this sticker is there, it has sufficient noise which is feeded into the data. And as a result, the model was not successfully able to predict that.
Actually, there is a lag. Maybe we'll just take a minute and we'll resume it. There's a lag in. Now I think it is in your video and what you're
Is it okay now?
saying. Yeah. Just a
Now,
second.
but no. Can you
No,
see?
it's
Is it working now?
frozen. It's freezing बीच में. I think it's the network.
Oh, maybe it's
Can
a
you
network.
just a second?
Yes. So basically, this, as I say, then one is a bias problem, which is really popular, and this bias problem comes with obviously the people who are designing with have they thought through all possible scenarios and having sufficient data point for that. The other one I was talking about is how do you fool a model with this sticker or patches? This is called adversarial patches, which is pretty popular. You can Google for it. It's called adversarial patch. And there are multiple use cases for that. People actually create a t-shirt around that where there's a t-shirt with a sticker. And what it does is this has enough kind of data like a noise, which is actually feed into the data frame of, let's say, a computer vision model. And when it's treating this, it actually gets confused because of that. I'm not getting into the
Oh,
technicality of how exactly it
interesting.
happens. Yeah. So basically, the way it happens is, yeah, let's say there, if you Google for adversarial patch, you can see that there's a model which is supposed to do object detection. And let's say there is a toaster and there is a banana. And if you put a patch next to the banana, it detects that as a toaster. So banana is identified as a toaster,
Oh.
just putting a sticker next to a banana. There is a use case where people actually was doing like there's a T-shirt which has the sticker, and
Mm-hmm.
if you wear that T-shirt and go through a mall or wherever there is a human detection, like there's a camera which detects that is a human being which is walking through the passage or whatever it is, you actually can get undetected because of the patches. So
Oh, wow.
so essentially, these are all various adversarial patches there. There is also an incident where this patches actually kind of convinced a self-driving car as a stop sign, and the car stopped in the middle of a road because it thought there is a stop sign because the guy was walking with the sticker was walking through the footpath of
Oh,
the street.
okay.
So these are called adversarial patches. So which is actually created by another, let's say, a machine learning person who understand the model and create this in such a way that this is called noise. You add enough noise to the data so that it misrepresent or detect as a wrongly identified object.
Yeah, it's I like that you call it machine learning person rather than, calling machine learning hacker. But
Right.
yeah, I think one and the same thing. But this means that it becomes all the more easy with the presence of adversarial patches and other such
Mhm.
mechanism to actually fool AI. Is there a way to, so many of the organizations, particularly teams who are listening, who want to use AI in that case, or ML for particularly, can they secure these models in any particular way? Like in normal development, we have these edge cases that we keep thinking of.
Yeah.
Is there
Right.
such a thing in ML development?
So basically, how we used to do it. Okay, and then one personally I have done is just to continue with the previous discussion is there's a facial recognition a system, and I myself have seen that there's a use case of obviously I cannot say which, like it's a pen testing an AI model, which company, but there was a model of a company which is very well used, and there was a use case. Let's say I've taken two pictures, one of Bill Gates and one of Mark Zuckerberg,
Mm-hmm.
and initially it was detecting this as a Bill Gates, this is a Mark Zuckerberg, and then I have created enough noise, put it into the picture of Mark Zuckerberg so that the picture looks, I mean, it's still not distorted. It actually still looks like Mark Zuckerberg. You can actually
Oh,
see and identify that this is Mark. But then if you put it in the model detects this as Bill Gates. So so there are
okay, that's
ways you can
slick.
create, yeah,
Hmm.
you can craft your data in such a way like that. Now, how do you prevent? So basically, there are two, three different ways you can do. One is obviously, see, yes, in security, we said nothing is 100% secure, right? So there is nothing which will make it 100% protected. So basically, there are a couple of things we see is, and which is very popular today in the LLM world, is people call guardrails. Guardrails is nothing but before the model, you do kind of a validation to identify, am I getting the right kind of data points or not? For example, when I'm trying to do this kind of attack, I may not be able to do it in the first time, right? So it essentially means there will be brute forcing is happening. Is there a way we can detect this kind of brute forcing sort of things happening? That could be one. Other is a lot of time this attack happens because the model is poisoned, which is model is fed into wrong set of data. The example I've given earlier, right? And then as a result, the model is misbehaving. So the way we say that you do it, any new model is getting deployed, you should have something called a golden data set or a perfect data set as a validation data set with which you validate is this model working or not. And so think of it like I have created a very perfect set of data set, and then with that data set, I create a kind of whenever I get a model, I actually validate with this data set and say that am I getting a certain level of accuracy or not? If I'm getting a certain level of accuracy, I know this model is better than the previous one, or at par, or it's below, right? So that way you can say, this model is no longer valid. Third thing, what we say is also in terms of this accuracy measurement using this golden data set and all this, we say is any data which is go coming to system, you should not simply a lot of time as it's a design problem, it's not an AI problem, right? The data should not be simply fed into the to the model. We should do certain level of data cleansing, certain level of actually doing a first layer of data validation, saying that okay, this is the data looks like the right kind of data, and then it should go into the system. But the catch there is, there might be bias. But if you do too much of filtering, that means you're probably sending a biased data. So,
This is
so it
tricky.
comes with experience. As I said, there's no straightforward rule of that, but putting a first level of validation is one. Detecting kind of a brute force is one. Don't expose your train API in public. Like when if you have a model which you want to train and you're creating an API, make
Yes.
sure there's a right access control.
I was trying to.
Fourth is
I was just seeing all, tons of us trying to train ChatGPT with the understanding that we have, to
yeah,
the extent that people are trying to fool and tell that 2 plus 2 is equal to 5. So I think people do all kinds of
mhm,
experiment when you open things up for training.
yes. And the fourth one is basically, as I said, you should always have a golden data set or a framework to measure the performance of your model to ensure that this is actually the kind of right level of accuracy you're getting. Last but not the least, one thing we personally did based on our, when we build our model is, see, at the end of the day, this is a probability we get. It would get like saying this is a or B. Like this is that the model says I think this is A, and my confidence is this X percentage. So what we have done is, let's say we create a set a threshold that if my model says that if the threshold of the confidence is not 97% or above, I will not let that pass as a valid kind of outcome. So you should set a threshold of also that, low confidence, result you don't allow to come out because that will lead to confusions also. These are a few things I can suggest as of now.
Yeah, this is great. Thanks for sharing that. I think setting the right thresholds, and this is a very high threshold, in fact, that most probably you're getting accurate data or accurate outcome in terms of what you want from the model, definitely. And
Mhm.
I can already see a lot of use cases. We're talking of use cases of using AI for organizations. Recently, we've been hearing cases where we have a lot of these LLMs and other GPTs being exposed, and then we heard of the case of Samsung, right? We had a lot of confidential information, business
Mm.
sensitive information, source code that was pushed to ChatGPT, and
Right.
particularly to assist in support and troubleshooting and a lot of these other things. But then these can also be used by other players because these are not protected always. So, what do you think are the best areas for an organization when they plan to use something like, for example, Gen AI, which is generative AI, or machine learning, which is provided by a third party?
Mhm. Mhm. Yes. So again, there's a lot of discussion happening on this. So actually, I don't know if you're familiar with not. There are different. There's a concept called AI ethics. That there's a new area which has been coming, which is AI ethic, or what is the ethical way of using AI. Is a different way people, companies are talking about. Even countries are talking about what should I allow as a policy or not. And I just wanted to deviate a little bit to share an example. I think there is one incident I just recently came across. There was a writer, I think in the US, and I don't know, it's a he. I think it's she maybe, I don't know, but she wrote a book where she used AI to uh, write the book, the content of the book or whatever, and essentially. the court has not given her the right copyright of the book because it's written by AI, not by the person.
Okay.
And a lot of people are in obviously in the favor of it, some people against of it. Some people said if
Hmm.
that is the case, then AI is a utility, that you cannot you cannot say this because at the end of the day, everything is an utility. Even the computer is an utility. If I'm using, let's say,
Hmm.
typing
Hmm.
my
Hmm.
thing
Hmm.
with the computer, then it should go to Microsoft or Apple or Dell, the manufacturer of the
Hmm.
computer. Right? So again, I'm saying AI ethics is a very interesting subject because things are shaping up now. Now coming to this enterprise segment, the same thing happened in ChatGPT also. A couple of, I think, a year back or something, there was an incident where GPT was actually able to spit out Microsoft access key, the Microsoft keys for the Windows. So,
Oh.
there is a prompt somebody has crafted and say that if you write that prompt,
Hmm.
the GPT model was able to give us the list of the Microsoft license keys of Windows, and but not
Oh,
sure
this
how
is
much of
nice.
that. Yeah, but then also the hallucination problem is there in GPT-1, so which means it fabricates data. So we don't know how much of that is actually coming from the actual data versus how much is actually fabricated or hallucinated. I have came across personal and experience where I was able to uh, kind of ask LLM to spit out Twitter username password of various users, although I didn't go further to validate are they
Mm-hmm.
actually
Oh my God.
valid or
Okay.
not.
Hmm.
But let's say there a prompt injection is such a big thing where you can do those kind of things. So essentially, what does that mean is that data is there's so much of data has been fed into it, and it has also the capability of hallucinate or generate, be creative. So it is able to give you a lot of this kind of sensitive data, but the question is always how much that is accurate is we still have to figure out. Now, long story short, for enterprises, typically what I suggest, this one is there are now options to do on-prem deployment of all these LLM models or chain AI models. If at all you really want to
Hmm.
use and you are protected, you actually use an on-prem system. Probably ask your team to look into it, how to do it, and deploy it on-prem. That way, you at least know that the access is restricted inside the organization. Now, on top of it, you can have access control. Very simple. If you inside the organization, also if you want given the access to certain set of people, it's just another resource of your organization. And now it comes into your IDM system, access control, and you can manage on your own. That is one thing we suggest. The other thing is obviously I'm seeing, especially in the startups and SMB segment, people blindly dump a lot of data into left, right, and center into the model to get summary of your documents and this and that, understand without knowing that the data has been shared out of this thing. A lot of times it's client's data also with whom you have signed an NDA,
Hmm.
and
Hmm.
so huge lack of education and awareness I see here, which is very important. I think then in enterprises we used to follow this data segmentation, right? What is called critical data, what is called,
Yeah.
let's say, shared data,
Classification of.
classifications, and it is highly important that that level of maturity has to be there now. So I see this can only be solved by good practices, and that can only come through awareness and maturity. I mean, I cannot put a gun on your head and tell always that what to do. I can put enough guardrails, but then at the end of the day, if you don't have that maturity inside you, you will still figure a way to actually bypass and probably share the data. But yeah, on-prem deployment, putting less access controls, creating a lot of education around it, because a lot of time people do it without knowing that how much damage they are causing. When
Hmm.
this kind of data, this kind of incidents have been shared with them, right? When they get to know that what, because of this, these are the so many big problems are happening. Then probably there will be more sincerity will come into the organization.
Yeah, I think this last point is so important. I think there needs to be a system eventually, but given the data classification itself is not easy, it is awareness that can help in many of these areas. Given that many of the systems, SaaS products, many products you have, organization internal APIs that they may come up with, which are AI enabled, all of them, we have to as users make a choice of what kind of data we are pushing into each of them. And I think that's a more practical way of doing things than, because this space could be, completely exponential in terms of
Yes,
how many
yes.
different
So
possibilities are there.
one thing I was fortunate enough to do in my early days of my career called pair programming. It's one of the extreme programming approach or agile approach. I think this is very much required in the space of AI, and especially AI security, because you need to have this validator and implementer model where
Hmm.
you sometimes you get so delve into this problem statement and you try to dealing with so much of data, it's highly possible that you are actually getting biased or doing something which you're not supposed to do. So one thing I personally recommend is, I think it's highly important you follow a pair programming approach for solving any possible AI solution model or any problem statement you're working with, whether it's with security, offensive, defensive, or whatever it is.
Yeah, yeah. So while you were talking about it, I was thinking of, last year, and you might also have heard, this was in March 2023 when this incident happened. And there were some users, and this is, I'm talking about OpenAI. It's one of the largest sort of AI providers, I would call it,
Yeah.
with ChatGPT and other systems that it has. There were some users who could actually see another active user's personal information, particularly profile related information like first name, last name, address, last four digits of the payment, the card information, and all of that. A lot of sensitive data that they could actually see. And, from time to time, we are also seeing that they can see other people's searches or the questions they're asking ChatGPT and things like that. So, my question is, particularly with attacks on AI providers, so whether it is organizations, security teams, normal users, whoever uses it, when the AI provider itself is attacked, it could mean a lot of things. It could mean that your data will be breached because they
Right.
have your data. It could also mean that when you are in session, some of these things will be stolen.
Mhm.
It could mean anything. Or when you're using the API that they are providing, it is vulnerable and hence your product is vulnerable. So there can be a lot of ways in which you as a user can be vulnerable because your AI provider had a data breach or
Mhm.
got attacked in this
Mhm.
sense. So what can teams do to avoid getting breached? Are there any specific guardrails that we can think of or put when we are building using this or when we are using these kind of systems?
So one is, I think, see, these are all connected. So we're getting into slowly into the supply chain attack, right? So your vendor is compromised. How do you protect your data?
I
But the
tend to
thing
get
is,
back to that, it seems, but yes, I think.
yeah, but this is a very special use case of that, which is basically it's not is the vendor owns the data, but I mean not only the vendor, but the solution itself has more intelligent and there's an easier way of getting data out of it. So, so yeah, I think if you talk about OpenAI or in general LLMs, right? A lot of this use case, the example you're giving is a pure play design problem, right? There's no proper access control. Probably they have not actually thought through, yeah, like insecure direct object kind of thing, right? So, why should I be able to see someone else's data point? But I think they, take it one step further. There is prompt injection attacks. That is a much bigger problem, which is also there because
Can you
a lot of
explain that a little bit
yeah.
for the audience?
So prompt injection is an attack where so LLM is basically a model, AI model, where you keep asking, you're having a conversation at the end of the day, right? With a
Hmm.
model like a
Friendly
human being,
conversation.
friendly
Yeah.
conversation. And this is the open-ended conversation. There is no, so if you talk about chatbots, it's at the end of the day as a chatbot, right?
Yeah.
So initial days, we call it as a closed domain chatbot, or what is basically initial chatbots were like menu driven. If you remember support, a lot of the support chatbot, when
Yeah. The
initial
IVR kind of.
IVO based, or even in the website also, like people have chatbots, even the WhatsApp based. When initially it came, chatbots, you see a menu options, and on that you select a menu, and then it will go ahead and do it. Which means I'm restricting my flow of work on a certain level. It's a more of a like a rule based. It's not a open-ended chat. Now with LLM, what happens is now we fed in enough data so that it has a lot of transformers, a lot of different underlying architecture, so it now can do a conversation with you. Now,
Hmm.
to do a conversation, it has to understand the form of conversation. And actually, it's a there's a metaphor. We call it as a parrot. It doesn't know what it says. It just thinks that this is a relevant thing to say because it has seen somewhere that it's been said this way.
Oh, this is an interesting
So
analogy.
yeah, so it's called the parrot problem, intelligent parrot. I mean, there are a lot of memes are there around this and all this stuff. So the idea is very simple. So let's say if I ask you something, let's say what is the purpose of your life? It actually doesn't answer by knowing that this is the answer. It's been fed in with so many times with different answers of this question, let's say, and these answers were given. by different people from different data source it came. It thinks that, okay, this is the most probable, most probabilistic way. This is the right set of word which I have to respond back with to this question. It actually doesn't have any intelligence to know that what I'm saying, right? So as a result, what is happening is a lot of time this data, if you ask the right kind of question. So coming into prompt injection, whatever I'm saying is a prompt at the end of the day.
Yeah.
So the way it comes is, I'm asking this question only. This actually goes as a prompt, and then it answers back based on the prompt, what are the data it has. Now the problem comes, prompt injection is where I create the prompt in such a way that I ask the model to do something else which it was not supposed to do. For example, just to give you an example, let's say I have a support chatbot on an e-commerce platform. It's supposed to guide me on what what should be the most possible, the most suitable product I want to buy, or maybe help me to troubleshoot on my delivery. It's not supposed to write a source code of a Python program if I ask it. If I can create a prompt in such a way that it actually now writing a Python program for me. So that's called prompt injection. I'm actually asking the model to do something else, which it is not supposed to do, right? And it is massive because the moment you get into that, or this is jailbreaking, because now to fix it, people have put a lot of rules to say that, I will not allow this, I will not allow to model to write a Python program or this, only do this. But then it's an evasion technique. If I create bypass that, I have broken that rule. So I'm inside the system now. Now the validators no longer is valid for me. Now I can ask whatever to do, whatever I want the model to do. And that is where you can extract out sensitive data of the company, sensitive data of the, if it is fed into those data of the competitors, of the other clients, whatever you want to do, as long as this data is available into the model. I hope you're able to understand. Yes.
Yeah. In fact, I wanted to add that because interestingly, we had a recent episode, which there definitely be. I'm sure that people would have watched it, but if not, I will link it in the description
Mm.
here. Was with Jason Street, and he was demonstrating that for some of the models where initially they say that, hey, we will not provide you how to hack certain things, and then he bypasses and figures that out, and basically is demonstrating that you can definitely fool them. It takes a few more
Yes.
prompts because you have to build
Yeah.
that and take it around the point, and then go back to where you wanted
Mm.
that specific information, and it gives you that, whether it is code or whether it is information, whether it is whatever. I think it's at a very naive place currently as a model, and I think as they mature, things may become more difficult. But it's always
Yeah.
a possibility, like you're saying, because blacklisting, as we
Yes.
know in our experience, even in security,
Right.
does not always work
Right.
100%.
Right. Now I will give you a thought. Okay, very interesting thought. And while you're talking, it came to me. Now we're talking about this AI botnet and all this thing. Think of it like ChatGPT has internet access today, right? If you have, and it has all the compute. Now, if you jailbreak and let ChatGPT do all the, let's say, the port scanning of uh, like uh, like uh, like the internet, and it can do that, right? So you don't have need a compute anymore. You're actually piggybacking on someone else's infrastructure
Yes.
to do that, right?
CPU.
So
Oh, nice.
yeah, everything like it's running, executing on a platform. If ChatGPT is running and millions of records coming per second, they have those amount of computes and memories and everything, right? So that can be, I mean, jailbreaking is a way of doing, and it has internet access. And if it has an understanding of doing things to that level, I mean, yeah, you can use your imagination and see how far you can go.
Yeah, I'm already using it and I don't want to call it out, but I think it would be obvious to many users. I think as matured users, we understand that it can use it for. So while we're talking about ethical hacking, there can also be unethical ways of attacking systems where this such systems can be
Right.
abused. And attribution also becomes difficult in such cases because now some other system is carrying out your attack. The IP address, you will trace it back to some
Mm.
common
Yeah.
models and things like that, or maybe Bitcoin mining. I think there are so many things where things could get abused, and there is a lot of room for working on all of these, specifically from a product perspective on the
Right.
AI side. Cool. I think this was an awesome discussion. Tamagna, I think especially thanks a lot for sharing all the beautiful nuggets of information that you had, especially with your experience. I think we learned a lot today on developing these models, particularly, and what are the things what are the different stages, how does it look like, the data, the training, and all of that, which demystified this space a lot for us. And the fact that we can use it for for security operations, but we can also use it for securing your own, within your own organization, if you're using AI, how to use it correctly, responsibly, and what organizations can do. Thanks a lot for sharing all of this with us today, and we'll see you all in the next episode.
Okay, thank you so much.
Thanks, Tamaghna. Bye bye.
Yeah, bye.
Hey y'all, if you enjoyed this episode, don't forget to like, share, and subscribe to Breakpoint Security Podcast. Your support means that we can bring more such conversations back to you. Share with your friends and colleagues, and stay tuned for more episodes from Breakpoint. Until then, bye bye.